Sorry, I was logged by the network. I think it will. Sorry, I was logged up by the network. It will not repeat itself. Some people are sharing my network, so that's why I warned them. Now, if you just neglect, just use Sunday. We want reading of Sunday alone. Forget it. Or either we should either Sunday or Wednesday, any of them. Let's say we choose Sunday. So you see that you can use as two independent groups. The people that use participants that take drug and participants that take alcohol. In this case, you have 10-10. That is 2 samples. Each of them is 10. You can calculate for Sunday, you can calculate for Wednesday, like that. Then you can consider in another way also as pair. Just forget about the type of drug they use. Your own is they take substance. You want to see what is their value on Thursday, on Sunday, compared with Wednesday. That's paired. Or see also, each of them are drugs separately. You compare Sunday and Wednesday. For people that take alcohol separately, compare Sunday and Wednesday. So paired. So let's discuss around it. Using the data set in the above example, let's imagine a scenario in which there is no difference in the depression level between drug and alcohol users. If we were to rank the data, ignoring the group to which a person belongs, from lowest to highest, if there's no difference between the group, we expect to find a similar number of high and low rank in each group. Now, that is, if there's no difference, if you say, oh, this really have, if 5 of this one have high and 5 have low, this one should be 5 have high, 5 low. It may not be exactly the same mark because it's the rank you are using. If we also added up the rank, we expect the sum total rank in each to be about the same. It may not be about the same if there's no difference. In the other way around, let's imagine there was a difference between the groups. Let's say the drug group is more depressed than the alcohol group. If we run the score, we will expect the higher rank to be in the drug group and the lower rank be in the alcohol group. If we also sum the rank in each group, we expect the sum of the rank to be higher in the drug group than the alcohol group. So look at the way it's being prepared now. Now, you will see, look at Wednesday. Look at the score. We now put rank in the score. We arrange the score in ascending order. If you look at it, 3, 5, 6, 7, whatever. We now put their rank. Of course, now since we have already arranged in ascending order, the rank, it is easy to rank. You won't be looking for it. It's easy to rank it to 1 to 20. Like that. The same thing we did for okay, let's leave Sunday. Let's just focus on Wednesday first. Now, the rank, actually, that's potential. What you just did that is potential rank. You know that in the class, if you say first, one person became first, 2 people became second. If 2 people do the same, maybe it's called the same mark, you not say you give this one a rank and give the other one the next rank. No. you accept that, okay, both of them are second, but there won't be third. If you see value like 35 now, you see number 16 and 17. So in the potential rank, both of them have even three of themselves, 16, 17, 18. So it will be unfair to put just one 16, 17, 18. No, both of them are the same. Can you see? 6 also, two of them have 6. So how do we do about it? So the first one, say 1, 2. Then when you now come to rank 3 and 4, because it's the same value, 6, 6, you divide the rank into 2. You add the right rank in and divide. So 3 plus 4 plus 4 is 7. Divide by 2, make it 3.5. So you now give rank 3.5 to each of them. So in that situation, you won't have rank 4 because you have already ranked 2. After the 2, you have already given the rank to 2 people. So you cannot have 4. You have 5. You have 6. You have 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, from that, you will have been 16, 17 now. You will not do like that because 3 of them have 35. That's rank 16, 17, 18, potential rank 16, 17, 18. So in that situation, you add it together. If you give it 17, you now give it 17 to all of them. So if you have already given 17 to 16, 17, 18, you cannot have. If you look at it, you give. So in this situation now, what will have been 16, 17, 18, you are giving 17, 17. You will now have 18. You know that we have already bypassed 16. You now have 18. You now have 19, 20. That is the actual rank. So for each of them, you need to identify each of them. Who we have added the group they belong. That's A. Alcohol is A. Drug is T. So if you look at it, most of the people that have those lower rank, they are alcohol. All those ones in the front, they are alcohol. Majority that have higher rank are drug. Can you see? It's only one that has alcohol around the higher rank. So if you now add their rank together, add the rank for drug is 151. Because drug, majority have the higher rank among them. Majority of the higher rank are drug. That's why when you add it together, it gives you 151. When you add it together for alcohol, it's 59. So the same thing we did for Wednesday, the same thing is done to Sunday. So in Wednesday, drug has 119.5. Alcohol has 19.3. So the Wilkinson ransom and Mann-Whitney U test both work on the simple explained above, the principle explained above. But when the group have an equal number of participants, the test statistic, which they call WS, for the Wilkinson ransom test is simply the sum of the rank in the smaller group. If both of them is not the same sample size, so the one that had the smaller sample size, whatever rank that one group get, that will be your statistic. That's for Wilkinson. When the group size are equal, it is the value of the smaller rank. When the group size are equal, it is the value of the smaller sum rank. Can you see now? So if the sample size are equal, like in this situation, the sample are equal, the value of the smaller rank. So that's what we use. So in this example now, the test statistic are 90.5 for Sunday. And for, is it that I mix it up? Wednesday we first of all did now. Yes, correct. Sunday is the one we did last. for Sunday and Wednesday respectively, 90.5 and 59. So for Sunday is 90.5, for Wednesday is 59 respectively. But if that's Wilkinson. But you know, we say that Man Whitney, they move further, they improve on it further. So you see that to calculate Man Whitney, you just one formula like this. Man Whitney is N1 plus N2 plus capital N1 into N1 plus 1 minus R over 2. R1 here is the higher rank, sum rank, the higher sum rank. So can you see now? If you do it for Sunday, you get 35.5. For Wednesday, you get 4. So let's run it. So if you look at it, whichever way it is, you see that the drug. Okay, let's just because this one you see the people. Just let's just go in. Let's go and run it. So who we run is Beck inventory, depression inventory. We share that one. Beck depression inventory. Or is there any question before we share? So only 5 of you. Let's say 4 because one person is the guest. So who is sharing? Mokhtar share for us. The other people are not ready. No, it's not the okay. You can go through, yes, under open. Open. Go to open, yes. Data. Beck's depression. That's number 3. Number 3 now on the left. And where do you go in Aruba? Yes. Are you sure it has not opened? Because you have to stop sharing this and share it again. Because the other one you did before that is still showing. Stop sharing the other one. And now share this one. Thank you.
Is it showing, sir?
Yeah, it's showing, it's showing. So you see now this air arrangement the way I show it. That's what it's showing here. You see that the substance from 1 to 10 is 1. I think is it not alcohol that is always drug. If you want to know the labeling, go to view. Go to view. Click, check that value labels. Check it. Click on it. Can you see? So 1 is drug, 2 is alcohol. The way you do it. So in case you are confused, that's the way we enter it. So you can see the Sunday, Wednesday. Forget about that difference and that thing. And where that difference, yeah, I think we'll use it for women. Okay, let's go around it. Analyze. You go to the same place. You not analyze, non-parametric, legacy dialogue. Now two independent samples. Two independent, thank you. Because we can see something. Yeah. Move them back in.
All day for.
So wait. Don't worry, is Wednesday. You put your this, just use any of them. You can use both of them. Click on both of them, that vector depression, those are the two score. Click Sunday and Wednesday. That's what you are moving. Move the other one. Thank you. That's all. Just click. No, it's supposed to be group. Yeah, click on group. Just like the way you do student T. Yeah, click on the group. No, click on that group now.
Which one, sir?
That group, click on that variable group. Okay, sorry, don't move the substance. The substance is the group now. Sorry. Move the substance there. No, you move it to that group. It's to the group now. Because that's the one that is their group, whether the person is drug or the other person.
Okay.
You move it to that arrow and yes. Click. Thank you. So we now want you to define. Define. Click on define group. Define group, the one down. And one. Drug is the one. So that is the higher one.
Yes.
Put one. Type one, and the other one type two. Click continue. Okay.
Are you seeing the result?
No, you have to stop sharing and reshare. So scroll down. Let's see. You will see the result now. Don't go too far, Jeff. It's okay. You see, look at the 119.5, 19.5. That's Sunday. For Wednesday, you see 151 and 59. Can you see? So when you come to their statistics, Sunday, you see, Wilkinson is a 35. Sorry, Wilkinson 90.5, already know before. Then the smaller, but the Wilkinson is 35.5. And my Whitney 35.5. Can you see? So most of the time, my Whitney you use. You can use now because the same p-value is applicable to them. So you will see. What can you see in the result? The one for Sunday, there's no difference. It's not statistically significant. The one for Wednesday, can you see, is significant because p-value is less than 0.05. Can you see? So that is the way to do it. If you remember, you look at the table telling you degree of freedom because the sample size for each of them is 10. You will see that the smallest one, which is the statistic for Wednesday, is far less than. It's far less than that critical value, which is around 10 or 11. We saw in the other one. So that's why 4. So the other one is not less than. The smallest one there is T, not less than. Can you see my video? So, any question? No question? Dr. Miller. Dr. Miller, are you in kitchen? Okay. You can stop sharing.
Sorry, sir.
You are gone.
Sir, how did we determine again whether it is statistically significant or not?
Look at this here now. It's even easier than look at the p-value now. What is the p-value?
For which one?
You know, we are running for Wednesday and Sunday. The p-value for Sunday and Wednesday, what is it? The p-value of the difference, test of difference between alcohol and drug users. Depression. We look at the p-value now. What's the p-value is less than 0.05? Have you seen it? So for the Sunday, the p-value is 0.269. It's far higher than 0.05. So that's why it's not significant. For Wednesday, the p-value is less than 0.01. 0.001 self. Look at it. That's what they are showing us. So it shows that it's significant. So what the interpretation of this is that there's no, on Sunday, there's no difference in the depressive symptom between alcohol user and drug user. Maybe because that is a Sunday. Some of them they don't even take. They don't take their normal. They don't take. But on Wednesday, it's different. Because maybe they take. You cannot see the difference, the effect of the difference between. Yes.
Sorry, my internet was misbehaving. You are calling me. I was trying to answer, but my internet was misbehaving.
Yes, I was saying, do you have question? Any question? That was what I was calling.
No, sir. No.
Okay. So, Mukhtar, is it clear now? So some Wednesday now they do so the drug people misbehave. They are different in their depression score between drug user and alcohol. Of course, you know that the depression is higher among drug users. Any other question? Okay, you can stop sharing. Let's move forward. I think it remain one or two. So we have done for one sample. Okay. What did I even say? Sorry, we have done. Share again, because we need to now rerun. You know, we just run for independent. We want to run the pair. You know, the two data sets they are in one, the way we did it. Yeah, go back. Now, the first thing you do is that you go to your data. Okay, no, don't worry. Yes, want to group it. Get to data. Click on data. Click on data now. So we want to so that they analyze it separately for drug and alcohol user. So data, go to split file. You know, I've taught you how to split file. Yes. Click on it now. I don't know where. Oh, yes, it's correct. It's correct. So click on compare group, because that's where. compare group. Move substance to that space. Substance. Thank you. Because that's their group variable to drug and alcohol. So what you want to look at now, you want to see the depression for each of them, for each drug and alcohol. The depression, you are comparing their depression on Sunday and Wednesday. Sunday and Wednesday. I believe the depression will be higher on Wednesday than Sunday. Okay, let's click OK. So we want the computer to analyze it based on that. Now, let's run the analysis now. Go to analyze. Analyze. Go to analyze. You can go to it from here. It's there. Give it to stop sharing. It's there. Go to analyze. Go to the same place now. Non-parametric test, legacy, dialog. There you go. Yeah.
Two independent samples.
No, two related samples, just like what we did that time. Two related. It's two related.
Okay.
So, you now move the first one and move the second one. Back depression on Wednesday, on Sunday, whatever. Don't know which one is where we don't know which one. No, why do you move return, please? You cannot move substance now. Substance is their group variable now. Remove that substance. Cannot move substance. Are you comparing the group? So we move the hand. Move. You know what I would love you to do? Go back. So I think because Sunday, the first one is, which one is the first? If you put your cursor, go back, put your cursor on that Sunday. Which one is Sunday? Which one is Wednesday? It's like the first one is Sunday. Yes. So you guys put Wednesday before Sunday. But the pressure is higher, I think, on Wednesday. So it will give you the result, but I don't want the interpretation to be given opposite sign. You may not find it easy to move Friday first, then move Sunday. So what you are trying to do, you are trying to remove Sunday from Wednesday. So it's already there. Click OK. Click OK. Great. You will see. Okay. We have not gone through. Okay. Okay, you have run it now. Just wait. Stop share. Let me share. I'll come back to it. I think we have not explained this one. It's only the two sample we explain, even though the data is in the same place. Let me quickly explain it. So this one now, the Wilkinson, the first one we did, is rank sum, this sign rank. So that first one is the non-parametric counterpart of independent sample t-test. But this one is non-parametric counterpart of pair t-test. It is used in the situation in which there are two sets of score to compare. But this score comes from the same participant. Just like what we do now. We are doing for drug user. That is, their depression on Wednesday and Sunday. For alcohol user, their depression on Sunday and Wednesday we're comparing. So it's the same person. before and after. So if we are interested in the change in depression level within people for each of the two drugs, we compare the depression on Sunday to those on Wednesday using Wilkinson sign rank. Look at it. So what it does is that so what you do, you look at it now. You see the other time, this is their score. The first column is this drug score, alcohol score. So the depression on Wednesday, depression on the first one is the depression score on Sunday, for both of them on Wednesday. Now, if you try to find the difference between them, you can see the difference. When you look at the difference, you remove Sunday from Wednesday, you can see this one got 13, even 15 from 28, 13, 35 from 35, 0, 16 from 35, 19, 18 from 24, 6, 19 from 39, 20, 17 from 32, 15, 27 from 27, 0, 16 from 29, 13, 13 from 36, 23, 20 from 35, 15. The same thing, okay. So when you look at it, the same you do for the alcohol. You remove when you remove it, you can see some in the alcohol now. You see a lot of them have negative. The other one is only 0 and positive direction they have. So the sign, apart from what is the sign of the difference of the distance? Anyone that reads 0 is high. You remove, it's already out, it's excluded. So you see, all these one here is positive, that is they are not minus, they are positive number. They look at here, we have a lot of them positive number and negative number rather, just one positive number. So yeah, okay, for each of those number, what is their rank? You remember the other time we have ranked this value where they are placed. Generally, we have ranked. So what is their rank? Look at it. Put the rank. So when it's not this rank, sorry. Because here now, you are ranking the difference. It's not you are ranking the difference. So if you look at the difference, 0 is excluded. Let's look for the Sunday for the drug. You see that when you remove that 0, the smallest is 6. That's why I put 1. So the next one is there are 2 of them, 13 and 13. Can you see the 2 13? So you cannot give E1 2 and give 1 3. Now 2 plus 3 make it 50 and make it 5 divided by 2. So each of them is 2.5, 2.5. Of course, when you have, there won't be 4. So the next one after them, there are 2 also. You see, 15, 15. So instead of saying 4 and 5, and 5 and yes, 5, whatever, is the other one that won't be 3 because there we have 2 and 2, 3. There won't there will be 3 rather. There won't be 3. So here we have 4 and instead of 4 and 5, we now add 4 and 5 to divide by 4.5, 4.5. So the next one in that area, no 5. The next one is 19, 9 value of 6. Then we have 20, value of 7. You have the last one, 23, give value of 8. The same thing you did here. You rank. So you see that the smallest, when you are giving the ranking, Forget about sign, no, just no sign. If you look at the smaller one is 2, that will give 1. The next one is 6, you give 2. The next one now, it should be 3 and 4 because I have 2, 7 there. And that's why 3.5, 3.5. That won't be 4. The next one will be, I think they are 2 also. 8, both of them 8. You give each of them 5.5. That won't be 6. The next one is 9, give it 7. The next one is 10, you give it 8. The next one is 11, you give it 9. So you will now get the last one, 10, number 15. So here now, we call this one sign rank. What is more important is the sign. The negative, you see, is there any negative? What are the, if you look at it now, those signs, you arrange there, are they negative or positive? All the one, you arrange all the positive sign, they are here. There's no negative. So for this alcohol, the positive sign, the negative sign, the positive, there are only one of them, only one that is positive. Then the rest are negative. When you sum, the first one, sum the positive sign, 36. The negative, 0. The one that have positive sign here is 8. This one, 47. So now that is how to compute it. For drug now is 36, 0. For alcohol, 8, 47. The test statistic is the smaller of the two. I 0 for drug and 8 for. So anyway, what we have shown is, I've already run it here. What the output that Mokhtar gave us. That's what I also put here. I've already put it here on the slide. So you see that so Wednesday and Sunday. For draw, comparing Wednesday and Sunday, just comparison Wednesday and Sunday. For draw, you see the p-value 0.012. For alcohol, both of them are significant, but the drug is more significant. So both for drug, the depression differ. For drug and alcohol, the depression differ between the difference between their depression between Sunday and Wednesday is statistically significant. Look at their p-value. I'm sure that's what. Okay, let's see now. You can share your own. Let's see. That's what is here. Share it back. Share the result back. So it's significant. Yes. So you scroll down. Let's see the statistics. Scroll now. You didn't scroll down. You see down now. You see the same thing. For drug, 0.012. For alcohol, 0.047. Any question? The significant in both. Any question? Okay. Stop sharing. I think the last one, this one is not even so important, but since we're already in it. The now one is called median test. Or though it's not, nobody even use, maybe just overlook that one because we don't even use that one. It's out of curiosity I eventually include that one. Yeah, and it's supposed to be but sometimes the way you call Sablic as if it's a chi-square, the way you do it. Let's just stop here. Any question? That will end up confusing you. So you can see now we have done for the 3 t-tests, 1 sample t-test, Wilkinson test for it. Independent sample t-test, Wilkinson rank sum test or Whitney-U test. The Whitney-U test, what is? But sometimes, if the work involves both, you are comparing 2 independent and before and after. There are people in medical something usually do it a lot. They will have 2 groups. You see, they have control, experimental. They will do for each of them before and after. So if you have quantitative something you are comparing with that, you compare in between 2 groups, you compare before and after for. So it makes sense if you are, because either you like it or not, once you compare before and after, and it's not parametric, though it doesn't, yes, we do that, but we don't actually require it because our samples are usually high. It is when some of those clinicians that do the work that the sample size is very small, because most of that they deal with patients, they may not have enough. We do with public, we deal with community. Most of the time, you have plenty of people in the community. So in their home, when they do that type, if the sample size is very small, you go to, before you know it, they may not be able to use parametric. So if you're using non-parametric, you see in between the 2 groups, you use Whitney-U. You now see in before and after, you use Wilkinson sign rank test. So because there's a Wilkinson rank sum test you can use instead of Whitney. Sometimes we use it like that. After all, the p-value is the same with the Whitney-U. Yes, so we challenge so that it makes sense. We do both Wilkinson rank sum test and Wilkinson sign rank test. It's quite interesting. But when you lay that, the reason I usually take you to this exercise, you can just always play with it now. Some of this you use it, just go play with it, play with it. If you want to hold our learning, that's where we first of all understand this principle. That's okay. How do we manipulate this thing with the computer? Any question? Because your people are discouraging me. As now you are late. What happened? And your friends not here. Mercy.
Sorry, sir. My network had issues and the link wasn't sent on time.
Yes, I know that I didn't send it because I was having network issue also. Because when I did it, the network was not good there. I have to now begin to run home. It was the issue when I have good network. Okay, tomorrow we'll be looking at ANOVA, analysis of variance. So until tomorrow. Good night, everyone. There's no question.
Thank you, sir.
Good night, sir. Thank you, sir.
Good night. Yeah.
Thank you, sir. Good night.
Yeah.
Bye.